Am I recording? Am I recording? Yes, sorry. Sorry, my voice sounds a little ronky and all. I feel like I'm catching a cold or something. But today I'm gonna show you how to convert your number into binary using in C++. So we, I define this function void binary, and our only parameter is gonna be x because that's all we need. And I already included this little prompt, so like, please enter a number to be converted into binary, and I'm gonna see in the number. And then, okay, yeah. So we'll start on it. So first, we're gonna define our initialize two variables. So int r is gonna be for like remainder, and we're gonna initialize to 0. And then int counter, we're gonna counter is equal to 0. Also initialize because that's gonna be like from that's how we're gonna define like our leading zeros. Cause for us, since like I have an assembly class, like we always use like each number like at 32 bits. I mean, and so that's all I'm defining here. So I'm gonna do cause I did this in assembly, so I wanted to do it in C++. So it's my first time doing it here. You know, like, I haven't coded in a while and in C++, so it's good to practice, I guess. So we're gonna do we'll do a while loop, and then it's much cleaner, I guess. So while x, because the way we convert that into binary is once the quotient, I'll keep dividing it, reaches 0, we stop. So while x is not equal to 0. I'll draw a picture, you guys can see it too. So, and then, so first we want to do the remainder because we don't want x to be changed before that yet. So r is equal to x divided by 2. And then I forgot my semicolon. Then x is equal to, I mean, we could do it like that. To the same thing as x equals x divided by 2. And then we want to increment our counter by 1 each time. And then, alright, so that looks right. Yeah, because the reasons we don't want x to be in front of this little expression is because if x is getting changed before that, the remainder is not gonna be like it's not gonna be modding it from the original value each time before. So x will be changed, but r is gonna be changed to it's gonna be a different x. I'll draw a picture. I'm not really good at explaining things. I'm more of a visual person. And then, okay, our counter is increased, so we could do this. The difference is equal to 32 minus counter. And I'll do a for loop to display those zeros. For int I equal to 0. I is less than counter. I mean difference. Kind of like 1 each time. And I just see how it's like a little simple for loop. And then I'm gonna do another for loop. So for int I is equal to 0, and then condition is gonna be while we could do it either less than or that or what. And it's gonna stop at the very point of it. So that's supposed to be an I. It's not equal to counter. Gonna increment. And then okay, I already defined it. So we're gonna define our stack first because we need we could use a list. I mean, we could use a bunch of things. You could use what's it called? a linked list, but we need a stack for something more easy, or an array, but a stack seems more easier on us since all the functions are already implemented, so we define a stack. And alright, good. I still remember the syntax for stack, so it's gonna be what's called SP for a stack pointer or something like that. Because in assembly, it would just be like this, SPs like that, and then and then so oh yeah, so now we're gonna want to see out. I want to see our stack pointer. Believe it's called top. Yeah, alright, that's right. And then we wanna, cause once that gets see out, we need to move it out of the way. So SP dot, it's not remove it. It's pop. Yeah, it's pop. Oh yeah, we need to be also pushing our elements in, right? And then yeah, and then we'll just define it up here. And then binary 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 num. I'm sorry, so much coffee today. Okay, so I run it. Yeah, so we don't know why that happened. So we'll do a number in binary, then we'll show it's actually that number. Okay, that's wrong. I don't know why. And do mod. I always mess that up. Alright, let's check it. Run it again. Um, 10 0 0 1 0 1 0. So now to prove it. So where's my painting app? Okay, so sorry, someone's coughing on my hurt someone's ears. Alright, so 10 and binaries, we're gonna do 10. This is harder on mouse, so 10 divided by 2, our quotient is equal to 5, because 5 goes into 2, 5 goes into that 2 times. And then our remainder is 0, and then 5 divided by 2, our quotient is equal to, that's a weird Q. Oops. That's even a weirder Q. It goes into that 2 times 2 is 4, blah blah blah. Remainder is equal to 1. 2 divided by 2. It goes in evenly, so that's just 1. Remainder is equal to 0. And then 1 divided by 2, that's going to be a decimal between 0 and 1, so I know that's 0, that's 1. Remainder is 1, when anything 0 divided by 2 is 0, so we don't have to include that. So it goes from this is what I mean, it goes that way. So it's 1, 0, 1, 0. And it's just 0, but 32 times, but 28 times. So 28 zeros. 0, call it 28 times. I know that's gonna be 0. I don't know how to express that. Yeah, so that's right. Well, there you go. Because that's basically for the oh my god, my boy, I'm probably ear raping somewhere now. So our remainder is this is r. So if we were to do this before, our quotient is now 5, so it's 5 divided by 2, we're gonna get 1 instead of that. So we need to include it first, so you guys can see that. And yeah, I hope you guys enjoyed the video and have a good one. Peace.